So in section 6.3, we learned about the separable differential equation, right? So where you had the differential equation was like dy over dx equals to a function, and then you were able to write the right hand side function as the product of function of x and function of y, and then you separate them. Dy and function of y will be on one side, and dx and the function of x was in the other side, and you integrate it, right? So that was the one of the very basic techniques of solving a differential equation. But not all of the differential equations are separable, right? In that case, we need to learn more techniques to cover more problems, right? So one of the type, and very basic and very important, is first order linear differential equations. What do you mean by first order? First order is the first derivative is used. That's the first order. Okay, the highest derivative used is first order, so that's why it is the first order differential equation. And if the differential equation has the form dy over dx and then plus a function of x only, px times y, equals to another function of x. Okay, you see that again? If the differential equation is given in this format, or if you change the given differential equation in this format, like just write dy over dx by itself plus a function of x times y and equals to another function of x. If you can write a differential equation in that format where p and q are the function of x or constant, then that type of differential equation is called linear differential equation. Linear differential equation. Okay, guys. Now, so the question is, how do we solve a linear differential equation? So to solve linear differential equation, we first evaluate IF. What is that IF? We call integrating factor. What is that integrating factor? We will see. Okay, so first of all, we find the integrating factor. Okay, and then we multiply that integrating factor to the whole equation. You multiply to the left side, integrating factor times integrating factor times integrating factor. But what is integrating factor? Is given by e to the integral of px, that px. Okay, e to the integral of px dx, whatever that is, you multiply all the terms of the differential equation, linear differential equation, by that integrating factor. Okay, and then after you multiply by the integrating factor, then the good thing about this integrating factor technique is, after you multiply the whole, all the terms by integrating factor, the whole left hand side will turn into d over dx, the derivative of y times integrating factor. The whole left hand side can be written like that, derivative of y times integrating factor. You will be able to write that way. And okay, and the whole right hand side will be qx times integrating factor. The right hand side will be qx times integrating factor after you multiply by the integrating factor, and the left hand side turns into derivative of y times the integrating factor. After you do that, you integrate on both sides, and then you will be able to solve for y. So you will be able to solve the differential equation. Let us see some examples there. Okay, guys. All right, so the first example is xy prime minus 2y equals to x squared. That's the given equation. Okay, so first of all, we will try to write in the linear format. Okay, what is the linear format? So we need to write y prime, or dy over dx, and y prime are the same thing, right? So by itself, so divide by x. What do you get? You get y prime minus 2 over xy equals to x squared over x is x, right? Because I was dividing all the term by x. Why did I divide by x? Because I want to write in that format. That this format has just dy over dx by itself, or y prime by itself. Is this linear? Yes, it is linear, because you see that dy over dx, it can be plus or minus, not a problem. 2 over x, this is like px, right? You see that this is like a px, this thing is like a px. okay, and this thing is like a qx. You see that? dy over dx plus px times y and equals to qx. It's like that, right? So to solve this, what we need to do, let us find out the integrating factor. Integrating factor is equals to e to the integral of px dx. How much is that? What is your px? E to the integral of negative 2 over x dx. That is px, right? So what do you get? You get e to the negative 2. Then if you pull the negative 2 out, you will get 1 over x. That will be natural log of x. You see that? Natural log of x. So, and this can be written as what? This can be written as e to the natural log of x to the negative 2. Okay? So basically this is e to the natural log of 1 over x square. That's what you get. Now, you know that e and natural log are inverse to each other. So basically you get 1 over x square only. So that is the integrating factor. You see that? That is the integrating factor. Now, after you find out the integrating factor, you multiply all the terms by integrating factor. So what I'm going to do is 1 over x squared times y prime minus 2 over x cubed. You see that? 2 over x cubed times y equals to 1 over x. Does that make sense? What did I do? I multiply all the terms by the integrating factor. This times 1 over x squared, this times 1 over x squared. So the 2 over x is there already. If you multiply by 1 over x squared, it will become x cubed. And there is x already, you are multiplying by 1 over x squared. So what do you get? You get x and 1 of the x cancel out. So this is what is left. After you multiply, always the left hand side can be written as d over dx y prime, the integrating factor. So always the left hand side can be written like that. So if you don't agree, you can just try. So let us use the product rule here. So it is like 1 over x squared times y prime, okay, and then plus y times derivative of 1 over x squared will be negative 2 over x cubed, right? If you use the product rule, f and then g like this, you will get exactly the left side of that. So I am able to write the left side, the whole left hand side, and this is always true. After you multiply by the integrating factor, okay, whole left hand side can be written as derivative of y times y times the integrating factor. That's what you can write, right? And that's what in the left side. And in the right side, so in the right side you have 1 over x only. Now what we do next is we integrate. Okay, let us integrate. So if you integrate, how that look like? You integrate that one, you integrate that one, right? So how does that look like then? So this can be written as the integral and the derivative will cancel out, right? That two will cancel out. So you get y times 1 over x squared equals to, what is the integral of 1 over x? This will be natural log of x and then plus c, right? You know what? For this natural log of x, you can just, there is natural log of x, so you can write like c as natural log of c so that you can combine, or leave it like that, not a problem. Okay, now because I want to solve for y, so what I need to do, I need to multiply by x squared on both sides. What do you get? Y equals to x squared times natural log of x plus cx squared. That is the final answer. Okay guys, now sometimes you will be given as like this. Okay, you will be given like this. Let me write down that. You will be given a condition like y at 1 equals to 5 or something like this. If this initial condition is given, then you need to find out c after you plug in x equals to 1 and y equals to 5. If you do that, let's say x equals to 1, what do you get? Y equals to 5. If that was the condition, then you will have to further do that, right? That means 5 equals to 1 times 0 plus c. That is c is 5, right? And what would be the final answer? Final particular solution at that time will be y equals to x squared natural log of x plus 5x squared. So you need to find out that one if the initial condition is given like that. Okay guys, all right? So the second example is solve y plus 1 cosine x dx minus dy equals to 0. So how do I write the dy over dx plus pxy equals qx format? So I want to write in the derivative form. Let's think of like this. Let's think of dividing by dx. What do you get? You get y plus 1 cosine of x minus dy over dx equals to 0, right? Now move everything on the right side. What do you get? You get dy over dx, right, minus y cosine of x. You see that? And then plus cosine of x equals to 0. What I'm trying to do here is I'm trying to write this format, the linear equation format, right? So it's dy over dx minus y cosine of x. Yes, minus y cosine of x. This should be minus as well, okay? This should be minus as well. Why is that? Because if you do that, it is like y cosine of x plus cosine of x minus dy over dx equals to 0. If you multiply by -1 or if you move everything on the right side, that's what it looks like, right? Now equals to, what I'm going to do here is I'm moving that to cosine of x to the right side. Now this is in the standard form, right? This is like dy over dx, and this is like px times y. You see that? This is like p of x times y equals to q of x, right? And this is dy over dx. So this is in the standard format. So this is linear. Now we can say that this is linear. You see that? Now it is linear. Now what do I do next is I want to find out the integrating factor, because it is the linear equation. So integrating factor is equals to e to the integral of what is px? Negative cosine of x dx. Okay, what is the integral of negative cosine of x? E to the negative sine x, because the integral of cosine of x is sine x, because there is a negative sign already. So that is the integrating factor. Now what I'm going to do, I'm multiplying all the terms by that e to the negative sine x. Okay guys, let us do that. So that will look like e to the negative sine x times dy over dx, right? And then minus e to the negative sine x times cosine of x times y equals to e to the negative sine x times cosine of x. That's what we got, right? And the whole left hand side, since this is the integrating factor problem, the whole left hand side can be written as derivative of y times the integrating factor. That's what the left hand side look like. And the right hand side is e to the negative sine x times cosine of x, not dx, right? Okay, now what we do, we integrate on both sides. Integrate. So this integral and derivative, that will cancel out, right? So what you get is y times e to the negative sine x, right, equals to, how do you integrate that? You should do sine x equals to u, right? If you do sine x equals to u, what do you get? Cosine of x dx, because when you integrate there is dx, right, will be du. You see that? That will be du. So that will be du. This is e to the negative u, right? So you will get e to the negative u du. So what is the integral of e to the negative u? Negative e to the negative u. That's what you get. That is negative e to the negative sine x. That's what you get in the right side. Okay. So let me write down that negative e to the negative sine x, and then plus c, because we always do plus c, right, when we integrate. Now you want to solve for y though. So how do I do that? So you divide by e to the negative sine x. So what do you get? You get y equals to, if you divide by e to the negative sine x, divide by e to the negative sine x, divide by e to the negative sine x, and divide by e to the negative sine x. So that will cancel out, that will cancel out. So what you get is y is equals to -1 plus c times e to the positive sine x, because I'm moving this negative sine x to the top. That's what I'm doing. Okay, so this is the final answer. Okay, so again, this linear differential equation solution method will be discussed in your differential equation class again. Okay, so this is just the introduction, and this is the second technique you learn, second and the last technique you learn in this class to solve a very basic type differential equation. Okay guys, thank you.